Okay, April. Um, as I said in the phone on the phone yesterday, I'm trying to um, explain change of basis. You know basis, right? So change of basis. What do I mean by change of basis? Well, implicitly, we've been using canonical databases. I mean, on database. I'm sorry, the basis. I was working on programming database. Canonical basis. Often, the canonical basis we refer to is actually identity basis. Well, if it's identity basis, I would say E1, comma E2, comma dot dot dot, and En if it's n-dimensional. And I know E1 is a vector, and E2 is vector, and E3 and En is all vector. If we're talking about transformation between Rn to Rn, domain and codomain Rn, and then we know that there are n vectors and also individual column vectors of size of n. So n by 1, another n by 1, total will be n by n. Again, this is, I just said, this basis is not a matrix set, but we often misuse or abuse our notation of I to indicate n by n matrix from that basis. So in this case, we use bracket, right? Vector and matrix, or they all use bracket to denote vector and matrix. So I'm going to have E1, and there's no comma or anything, and next column is occupied by E2 dot 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 in En. Therefore, it's going to be n by n matrix. So when we say change of basis again, and we want to use different basis than this I, which is n by n, different basis than this I. Here we'd like to use a C, which is new one. In this case, I'm going to introduce the column vector of this C with v1, v2, dot dot dot, vn, because we use vi, or this vector and vector, as just like a typical vector that we've been using. So C is new change of basis matrix. Again, C is called change of basis matrix because it's a matrix. What it consists of? It consists of those vectors that has v1 and v2, vn, like that. But we use another notation B, which is set, which is basis. Basis is always set, right? Basis B is v1 vector, comma v2 vector, comma, and then vn. That way we notice by listing v1, v2, and vn with comma that this is a set of linearly independent vectors that actually makes basis. Okay, so my next, how do I move my screen? No, I'm just, okay, yeah, never mind. Now what I'll do is that actually I'm going to introduce the change of basis. Change of basis from I to C. In other words, if I have a vector x, this x could mean, sometimes I put the bar to denote vector, but your book, your printout doesn't have bar over bar notation, but it's very common. In practice, people use the bar notation. So, pretty distinguished with bar or without bar. Sometimes I try to be consistent. From now, I'll use bar, okay? Bar to denote the vector. So this vector could mean two things again. This vector could be an element of your domain or codomain of Rn, or this x vector could be a column vector x1, x2, these are all coordinate, dot, 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 and xn, and then have n by 1 coordinate, n by 1 column vector. So they use this x bar interchangeably between these two. Again, this one is abstract. This is actual realistic implementation or realistic representation rather for this abstract concept of vector. Now, when we say x bar, x bar, then actually that means abstract vector x, but written in terms of I. In other words, I is the collection of column vectors of E, right? E1, E2, En. So that's what that means. Also, you want to transform that one to Y, which is Y, but in I. Again, we know Y is same as transformation of your vector x, but written in I. I don't know why my writing is always slanted like that. I try to adjust my tablet here. And then similarly or appropriately, we introduce A between this x and y, between this x and y. So we can write y vector is equal to a x prime. In this case, we all assume that this x and this y's are coordinates. Well, coordinates is just column vector, right? So I got a matrix multiplied by column vector, gives me another column vector y. So that's A. A is just a transformation matrix between domain and codomain in identity matrix or canonical basis. Here we like to introduce another vector D. Oops, that's my D, and this D is again my x is written again, my x, abstract x is written in terms of B basis, Then I have, it's going to apply pre-multiplied by D. When I say pre-multiplied makes the D, 2x means dx bar, y is equal to, again, B. I think I got cut off over here. Sorry. I tried to write in small, but okay. So moving down. Again, the maximum video size is 10 minutes. So I'm going to stop somewhere and then continue. Currently, I record about 8 minutes 40 seconds. So, okay, why? Okay, now summarize and before I stop and then continue to next one. I have a vector x and this y, and that is represented A, and then I have, of course, this x is based on identity canonical basis. For that case, we introduce this A as a corresponding matrix. Here I have D is almost reaching 10 minutes. So okay, X, and now I introduce B and Y, B. So I got A and D. The relationship between A and D, that's what I'm going to explain next video. Okay.